All right. Thank you for being here, everybody. Before we get started today, I just wanted to mention a couple upcoming webinars that we're going to have in the next few weeks. Our most recent one will be tomorrow on May 21st, and that's going to be an ergonomics webinar entitled Bilateral Assistance from Active Knee Exoskeletons to Reduce the Difficulty of Occupational Lifting and Lowering Tasks. That's going to be with Grace Hunt, PhD, and in collaboration with the Rocky Mountain Center for Occupational and Environmental Health. On May 28th, we have a doubleheader with the California Labor Lab at UCSF. Nicholas Smith will be presenting on risk and protective factors for farm workers' health and well-being among Latino and Hispanic farm workers in Oregon from a study that he's done. And then Heather Amato, PhD, MPH, will speak on tracking antimicrobial resistance on farms in California and Maryland. Then on June 10th, we're going to have another industrial hygiene webinar with John Moore III, PhD, on the use of artificial intelligence in occupational and environmental health and safety. We hope to see you all there. You can always find out more at www.coeh.berkeley.edu/webinars. So for today's webinar, just wanted to welcome everybody on behalf of education and research centers throughout the country. We are pleased to present the Industrial Hygiene webinar series. This collaborative effort on behalf of each ERC's continuing education program aspires to provide access to current research supported through NIOSH ERC programs. Thank you all for joining us. Today's webinar, entitled Beyond the Call, Industrial Hygiene Strategies to Protect Emergency Responders, is presented by William A. Jetter, PhD, in collaboration with the University of Cincinnati Education and Research Center. Just a few housekeeping items first. You will all be muted during this presentation. If you would like to ask a question, please enter it in the online Q&A box. You'll find that at the bottom of your Zoom window. We will save time at the end of the presentation to address as many questions as possible, and we'll also have the chat open. Feel free to use it to participate and join the conversation. This presentation is being recorded and will be made available on the Center for Occupational and Environmental Health YouTube page within 5 business days. All participants who logged in with their registration email for the full live presentation today will receive an email tomorrow with a link to an evaluation form that will qualify participants for a certificate of completion worth 1 continuing education contact hour. Once the evaluation is completed, you will be able to access and print your certificate. Now I'm pleased to welcome our speaker, William Jetter. Dr. Jetter is a 47-year fire service veteran and the city manager of Deer Park, Ohio. He previously served as EMS and fire director and fire chief of the Monroe Township, assistant fire chief of Glendale, and EMS and fire director of Sycamore Township. He's an adjunct faculty member at the National Fire Academy, Ohio Fire Academy, University of Cincinnati, and Cincinnati State, and he holds a PhD in fire safety management and certifications, in fire safety, hazardous materials, and rescue technology. He has lectured nationally and internationally and authored Artful Ascension and The Little Green Fire Truck. A fellow of the Institution of Fire Engineers and past president of its USA branch, Dr. Jetter has been nationally recognized for his contributions to fire safety education and emergency response training. Dr. Jetter, thank you so much for being here today. You have the floor.
Well, thank you. Want me to share my screen now?
Yes, you should be able to.
There we go. Okay, afternoon, everyone. And today's going to be a little bit a different presentation, but we're going to dig into some strategies that we're suffering in the emergency response category with not only responders and firefighters and police officers, but also public workers as well. This first slide that you see is actually a fire from in Greendale, Indiana. This was a Seagram's warehouse fire. This was a building that was basically transitioned into a plastics warehouse. And what you see is that large column of black smoke, which is loaded with hydrocarbons and particulates of combustion. And quite frankly, the biggest problem was a huge environmental issue with this fire, with the runoff of this particular fire ran right into the local water supply called Tanner's Creek. So we had all kinds of environmental issues, hazmat issues, and we also had a very extensive decon issue as well. So to kind of give you an idea where we're going to go today. On my screen, there we go. So things we want to take away is identify key occupational health exposures faced by the public safety professionals, analyze the trade-offs between public workplace safety and operational effectiveness, in these professions, evaluate the effectiveness of current legislation's efforts to address health and safety gaps in public service, then compare the national and international approaches to the worker projections. So identify occupational health exposures facing today's professionals. And what I list at the bottom here is factors of concern, which includes death, permanent disabilities, heart, cancer, occupational exposures, risk factors, injuries, falls, biological exposures, and unknowns. A little before we move forward, I've been engaged with the University of Cincinnati Department of Medical College and also Environmental Services, as well as the Engineering Department on studies on firefighters. And we've accomplished a lot. Right now, we're in the process of developing a smart garment, which is a garment that will basically be incorporated with the fire coat for cooling the firefighter to maintain a core body temperature, which is really important. So some data that we looked at, this is over a period of time from 2090 to 2006. Most of the firefighters' fatalities during that period, and it goes to about 40 of them a year, were due to heart attacks or heart-related incidents. And during that same period of time between 92 and 96, we had asphyxiation problems. Some of this has been resolved with the improvement of the SCBA, self-contained breathing apparatus, and that went right across the board, not only for firefighters, but in tactical SWAT teams and also to an industry as well. One of the biggest problems was trying to reduce exposures, but at the same time, keep in mind heat progresses through this specific time. We found out a lot of things about how the heat evolved and caused some issues with just people in general. The last thing you see is on burns. And I want to talk a little bit about burns in a minute, but the biggest thing is in 1996, I was in a fire and I basically got thermal burns from a pair of gloves I was wear testing, and it didn't have the inner liner. I'm lucky I got my hands to be used today. I have one deficit, and I can't regulate heat or cold in my hands. But I will tell you, burn centers are the lifeblood of anyone that gets burned. When I went to the University of Cincinnati's burn unit, I was amazed at how many people were far off than I was, and how the treatment was maintained itself and brought them new hope in their life. So I'm really excited about burn units in the country and how they're addressing burn victims in general. The next thing we looked at was injuries of firefighters. The red is all injuries, and as you can see, from 1990 to 2006, we didn't get down very low. Most of we got is right around 40,000. Maybe at one time in 2002, 2004, we were right above 30,000 firefighter injuries. Most of these are other injuries, and the blue line at the bottom is nothing more than slips, falls, and jumps. And we thought, what was causing that? We noticed that in some cases, the firefighters that have been actively engaged in firefighting a study that we looked at was about how much carbon monoxide are they exchanging in their body and what was being retained and what was causing some problems. We looked at the myelin sheath with how the effects of carbon monoxide does with the nervous system. And you'll see right around 2001, we had a lot of injuries. This is when the transition occurred with SCBAs, and that was desperately needed. At that time, we also went through what they call the Sebring standards for chemical, emergencies with cybernetic, excuse me, cyber attacks and that with biological emergencies. All those things start to come into play right around 2001. So one of the things that came out of this, and I'm zeroing this little part of the segue into, we really realized that we had to have a risk management model. And part of that was the fact that we've decided that after numerous firefighters were killed in buildings and public workers were also killed in construction accidents and everything else, there has to be a risk management model put in place. So the first thing we did was come up with 8 functions of command. This came from Alan Bernascini. He's the fire chief of, was the fire chief of Phoenix, Arizona. He put this plan together years ago. And it didn't sit so much on the shelf. He implemented it within his own department in Phoenix. But one of the things is that we all realized that it was something very important. So you have the deployment, you have the assumptions, you have the situation, the strategies of the incident planning, communications, organizations, and then naturally you review, evaluate, and continue with revisions. And then at the same time, you continue on and terminate the command. This is the model that's used today on large scale incidents or even just a simple incident. By doing this, we've been able to address training deficiencies, also to what other deficiencies we're seeing in turnout gear and also in the workplace with the way people respond to things. So it's been a useful tool for benchmarking against these strategies. The factors affecting cardiovascular and thermal strains are, this is a small one, but this is basically environmental factors that we deal with every day. If you work for municipal government, waterworks, sewer department, this model works for everything. When you're looking at the maintenance department, and like in my own community, they do storm sewer work. The work performed is important. The PPE, proper fire or proper PPE protection gear, thermal environment, individual characteristics. Are they wearing their gear right? Are they using it right? Medical readiness. Are they healthy? Physical fitness, hydration levels, and then the looking at the whole response, physiological issues that go with it, personal factors. We find that by looking at all this, it starts dealing us into a direction of how people work and perform their duties. It doesn't mean if you're a firefighter, you're doing everything right, and the maintenance guy putting a sewer in is doing everything right or wrong. These are just factors of contributing issues that cause injuries and also stress. So we looked at stress and looked at the hot environment. Now, if you don't think the average maintenance worker working on the streets is not in a hot environment, then that's your opinion. I believe these guys work around asphalt when it's when they're putting the asphalt patch in hot weather. You're looking at 250 degrees of the product, and along with the heat that comes off of it, and they're working and doing what they got to do. When I was out of Phoenix working with Alan Bernascini, the fire crews carry 2 sets of boots. When it's real hot out there, the pavement, their boots actually, if they're standing, melt and basically stick to the pavement. So they have to turn around and pry them off and turn around and change into other footwear for their protection. But the biggest thing out of all this is the heat loss or the reduction heat gain by convection or radiation. Now the sun, we get our ultraviolet rays and radiation from that as well. But convection is the heat transference that we see all the time. Heat goes to our skin, it vacillates into other items as well. But that vacillation that goes on is the heat transfer from the core to the skin, and then also to, you're looking at sweating, you're looking at heat loss by evaporation. This is normal for everybody, not just firefighters, not maintenance workers, police officers, anybody. This is a normal benchmarking that we see in the heat stress arena. So we did some calculations, and calculations come down to body heat storage, metabolic heat production, heat gain or loss due to convection, heat gain or loss due to radiation, or heat loss due to evaporation. Now, I'm going to segue a little bit off the beaten path here. One of the things is that when you look at heat loss or heat generation in the fire service, we train our people in fire behavior of conduction, radiation, and convection. This is the heat process that we see. We're also seeing that being segue into some of the police stuff. The reason why for this is the fact that they got to be understanding of where the heat's coming from and how it's going to affect them physiologically and also an environmental situation. So the big thing I look at here, this little simple formula gives us some idea where we're going as far as metabolic heat production, heat loss and gain, heat gain and loss due to radiation, and heat loss and gain due to evaporation, which is a key thing we're going to talk about. I'm going to show you this video. This is a firefighter under stress. He's fallen through a roof. Now, the reason why I bring this to you is because look at this when you're sitting there, and I don't know how many of you in your life have been in a near death situation or near panic situation, but here's a firefighter on a roof, and the roof collapses underneath him, and here he is trying to survive. That little clip gives us an idea of the stress that someone suddenly is encumbered with trying to survive a dangerous situation. I think, quite frankly, he's done a great job. He went back to work and he was fine. But the problem we have more than anything else is the fact that those situations for firefighters are near miss. Look at the police officer. Look at where we're at today with public works workers on the highway, and that. So what we did was we started looking at how the stress is on firefighters in the under fire conditions. This was a long study that we did at the University of Cincinnati. This is a burn building that we used at Coleraine Township, and by doing this, we were able to monitor the physiologic state of firefighters. Now, in this case, you got a firefighter advancing a hose into the building with a firefighter at the door. There's two things going on here, and every one of them are wearing full turnout gear. We got one on the side hasn't put his gloves on yet, and another one is standing by. So the firefighter can lose a significant amount of water weight while wearing the fire gear due to the increased sweat production, including hot, strenuous environment. Now think about this. When a firefighter enters into a working fire or a police officer goes in a building that's hot, you're looking at increased temperature, not the temperature, you're looking at increased water evaporation. Sweat is a big one. During a 30-minute activity, firefighters can lose up to 40 ounces of sweat, and then it can be increased to 70 ounces of sweat. I can attest to this personally. I've been in numerous working fires, and I've lost a pound of water easy from a fire. So that's just me, okay? But every firefighter is a little bit different. So the big thing is you see what goes on. I'm trying to answer a question. So, okay, let's move on.
We can save that question until the end, Dr. Jetter.
Okay. Um, we equated this to some simple activities that every one of us equate to. Walking is about 3.5 miles per hour in the sun with an air temperature of 100 degrees Fahrenheit loses 1 quart of water an hour. Driving a car under sun with the air temperature of 100 degrees, this is three quarters of a quart of water an hour. Sitting in the shade at rest with with air temperatures of 100 degrees, this is a cup of water an hour. So you can see activity and semi-activity and rest all come into play in regards to how much water weight we can lose or evaporation of water. This little model shows you what we're up against in our body being affected by radiant heat, convectivity, and heat gain. You're looking at vaporization loss through the body. We're also looking at how, in this particular case, they have a helmet on, but you lose water through your head too. And the problem with that is that you start seeing some other effects of that as well. So conductive heat gain is, the metabolic heat production goes into a little bit of a cycle. So the problem is that with the vaporization that, does the person become a little more hypothermic with the heat loss, or do they sustain themselves regulated accordingly? Everyone's an individual. And when we did these studies, we start seeing the differences with individuals. So heat countered by evaporation versus heat via sweating is one of the things we looked at. So we looked at public workers, okay? And we looked at environmental, uh, industrial sources, climate, PPE. Some maintenance workers wear rain suits for when it's out in the rain. They got the vest on. We also looked at the police with a ballistic vesting equipment and gun butt in doing an assessment on police with the additional equipment. They put on to their body another 20 to 25 pounds of weight. Firefighters wearing full protective clothing with an SCBA put on 50 pounds of weight. So you can see by them being active, they're going to sweat and they're going to blow a lot of water off their body. And by doing that, you can see where they can run into some complications. So we look at metabolic heat, basal heat productions, and the rate with that, the amount of energy an individual needs to maintain a basic function. This is like just breathing, circulation, maintaining body temperature, or is essentially the amount of heat generated in the body when it's at rest. So when we looked at this, we looked at firefighters when they sleep. We also looked at individuals when they sleep. We also looked at basically anyone. So there's a common goal here. When they're at rest, their basic body function is working to produce the heat that they need for basic functions. When we looked at work heat production, there was 5 methods of heat productions that we looked at closely: combustion, nuclear, resistance, electrical resistance, chemical reaction, and friction. Conduction, convection, radiation, and evaporation were all byproducts of heat production. One of the things I put in here is a battery overrun generated by heat of a lithium-ion batteries in vehicles and normal house use and industrial applications and storage facilities is now commonplace. We've had several firefighters, several facilities overrun by the ionization of the lithium-ion battery. And what happened is we have those, and what's going on, even especially with the cars now, with the electric cars, you're running into runaway situations. New York City has got a big problem with electric bikes. And what happens is they put them in the hallway of their apartment building, tenants and that, and they put them on charge, and then they overrun electrically and cause a fire. And this is happening more and more throughout the country. So one of the things is when you're looking at heat production, you're looking at an electrical resistance problem, but you're also looking at a chemical reaction along with that. This is what people in the public sector, people that protect you, police, fire, public workers, these are the things they're dealing with. Garbage collection is another one. Our local resource in my community is Rumpke, and they have recycling facilities. And with the lithium ion batteries, they average some sort of fire every day in that facility. So you got to be very careful in how you deal with that, because a bunch of it together is fine, but putting it out is a real problem too. Do you use water? In some cases, if it's a car fire, an electric car fire, you're better off putting a blanket over it and smothering it so that you can reach that factor. But look at what a firefighter and a police officer and even a Rumpke refuge driver is up against with a runaway heat situation and adding stress to their body, and the heat factor goes along with it. So one of the things everybody says, well, what's happening legislatively? Well, there's a lot of things going on. Some of it isn't vital. Everybody knows right now we're going through some transitions in regards to research grants and facility of different programs that are going on through the federal government. OSHA controls a lot of things for us. Not NFPA controls a lot. NIOSH also controls a lot. But one of the big factors is that whether you live in California or Ohio or whatever, the Bureau of Workers' Comp is engaged in firefighter and workplace safety. And it's not just firefighters, I mean everybody. And the reason why they're trying to do a risk plan there to reduce the amount of injuries from workplace injuries that are caused by heat, stress, and also to equipment failures. And I'm going to show you a little video here in a minute. The International Association of Fire Chiefs has been engaged nationally and internationally on how to control these safety gaps that are out there right now. Me being a fellow with the Institute of Fire Engineers, what we do in the United States is somewhat different than we do internationally, but we all suffer some of the same problems. And that's just something we all have to look at. State and local government has put imposed some restrictions as well, which are good. And the problem is that's how things happen faster sometimes. But the biggest problem we got in the public safety arena is that we have got to uniform our standards more so that it protects the employee across the board. It doesn't matter where you work, what you do for the public, it's how the standards apply to you. One of the things we looked at was metabolic heat. There's a little graph that we put together for you all. And I'll tell you right up front, it's interesting the fluctuation in the graph itself. We have the threshold limit value, and then we have the action limit. Historically, there's some differences there. But the biggest problem is when we start looking at the core temperature. If you look, 32 to 40, 34 is not that far off. So we're looking at what's the limit of the core temperature to 38 degrees. So we've got to look at how we can manage this across the board more effectively. We found out that the core body temperature goes up. This was the whole nemesis of this research with heat stress and everything else. As the core body temperature goes up, we start looking at major deficiencies in person's functionability of realization of health and continuity. Heat acclimation is part of it, blood flow, distributing of cardiac output, lower thresholds for sweating. Sweating output is really key, and low electrolytes. If you see this little graph right here, one of the things we put out, it was when active cooling began. This is when we did a study. We started the activity, we had the rescuers sit down, And then all the way at the top of the grayscale there, you see how active cooling began. Now you're looking at temperatures or for per minute beats. Their heart rate went up to 140 beats a minute. In some cases, if they start the activity and it went down, that was good. But you got the core body temperature in the gray, you got the heart rate going down. The problem is when it peaks out, I'm sorry, I read the chart wrong here, but when it peaks out, you have some issues going on. So they got to look at how this whole thing comes together. These are some examples of personal protection gear that you got firefighters, the level A suit, and then also a maintenance worker in a building with a SCBA or supplied air system. Exertion, wearing the apparel, and an inadequate rest. Now, we also looked at the fact that when people were in these environments, how much rest did they really get? So there was a combined effect of that. You can see where we're at with the watts, meaning the type of energy, and then not resting, and then wearing an apparatus and walking. We put all that together just so we could look at the heat load and also how the person physiologically is working. I want you to look at this video because this is what happens in industry every day.
4,000 pounds of acetic acid mixture erupted from equipment when 3 contract workers inadvertently removed critical components of a valve. All 3 workers were sprayed with the acetic acid mixture, fatally injuring 2.
Unfortunately, this is not the first time that simple maintenance of a plug valve ended in tragedy. Our report and recommendations aim to help prevent incidents like this one from reoccurring.
LyondellBasell is a plastics, chemicals, and refining company that owns and operates facilities in 32 countries. The company's LaPorte, Texas complex is the world's 3rd largest producer of acetic acid, a flavor enhancer and food preservative. Acetic acid is a corrosive liquid that can cause severe skin burns and eye damage upon exposure and can be harmful if inhaled. On July 24th, 2021, an operations technician discovered a small leak from piping in the complex's acetic acid unit. The piping was located upstream of the unit's acetic acid reactor. Shortly after the leak was discovered, the shutdown of an adjacent process unit required the acetic acid unit to also shut down. Personnel decided to use the opportunity provided by the shutdown to fix the leak. To isolate the affected pipe section, company personnel decided to close the plug valve located between the leaking pipe and the nearby acetic acid reactor. LyondellBasell planned to remove the valve's actuator, which is equipment that opens and closes the valve, so that they could lock the valve in the closed position. Since 2019, LyondellBasell had used a third-party contractor, turned to specialty companies, for general mechanical and maintenance services at the facility. Turn 2 communicated to LyondellBasell that it had a night crew that was qualified and available to remove the actuator. But LyondellBasell did not have a procedure detailing how to remove the actuator, and neither LyondellBasell nor Turn 2 trained the contract personnel on how to remove the actuator. On the evening of July 27th, the Turn 2 foreman and 2 pipe fitters began working to remove the actuator from the plug valve. In doing so, they inadvertently removed pressure-retaining fasteners that were holding the valve cover in place. These fasteners should not have been removed to uninstall the actuator. Not recognizing that they had compromised the integrity of the valve, the team continued to remove the actuator and associated equipment, including a coupler. But the coupler was stuck on the valve stem and could not be easily slid off. Therefore, the workers decided to use a tool to attempt to forcibly remove the coupler. The combination of forces from the tool and the process fluid pressure inside the plug valve caused the compromised valve to fail. The unfastened valve cover and plug forcibly ejected from the valve body. A chemical mixture, primarily composed of acetic acid, rapidly erupted through the open valve. The entire contents of the acetic acid reactor, roughly 164,000 pounds of hot acetic acid mixture, emptied through the open unplugged valve. All three turn-2 workers were sprayed by the acetic acid mixture. The turn-2 foreman and one pipe fitter were fatally injured from chemical burns and inhalation of the release. The third worker was seriously injured. 29 others sought medical treatment. The Chemical Safety Board launched an investigation and found 2 safety issues contributed to the severity of the incident. They are valve designed to prevent human error and providing workers with conditions, procedures, and training to safely conduct work. The first safety issue is valve design to prevent human error. During its investigation, the CSB discovered that there had been at least 4 other serious incidents that were the result of workers inadvertently removing pressure-retaining components from a plug valve while attempting to remove an actuator. All of these previous incidents resulted in fatalities or serious injuries. The CSB believes that the recurrence of these types of incidents points to the need to redesign plug valves so that it is very difficult to accidentally remove pressure-retaining components.
Best way to address this type of incident would be by prevention through design of new plug valves. But in the meantime, facilities should clearly label pressure-retaining components on existing plug valves. For example, the color-coded paint and warning signs so that workers can identify them more easily.
As a result, the CSB made recommendations to the American Society of Mechanical Engineers and the American Petroleum Institute to revise their plug valve design standards to require facilities to clearly mark all existing plug valve pressure-retaining components and require that new plug valves are designed to prevent the inadvertent removal of pressure-retaining components. The second safety issue found by the CSB is providing workers with conditions, procedures to safely conduct work. The CSB found that LyondellBasell did not thoroughly assess the risks of the actuator removal work to ensure that sufficient procedures and safeguards were in place to prevent exposure to process fluid.
At some facilities, a risk assessment may determine that depressurizing and de-inventorying equipment is required before removing plug valve actuating equipment.
The CSB also found that LyondellBasell failed to provide the turn-2 crew with a written procedure and allowed the work to be done without LyondellBasell's oversight because of the perceived simplicity of the actuator removal. Furthermore, the CSB determined that neither LyondellBasell nor Turn2 trained the work crew on the steps necessary to safely remove the actuator.
Had LyondellBasell performed a risk assessment to ensure safeguards were in place during the actuator removal, as well as provided the Turn2 work crew with written procedures, proper training, and oversight, this incident could have been prevented.
As a result, the CSB recommended that LyondellBasell update company policy documents to require that procedures are developed for properly removing actuating equipment from plug valves and to require verification that contractors are competent, adequately trained, and qualified to perform work.
As this tragic incident has shown us, even a simple task can turn deadly if it is not properly performed. It is time to improve the design of plug valves and take other protective actions, such as ensuring that clear markings are visible on all existing plug valve pressure-retaining components, and workers are properly trained before conducting maintenance. Vital steps like these can go a long way in injury prevention and help save lives. Thank you for watching this CSB safety video.
For more information, please
as we're coming to a close, one of the things is the high risk of heat stress in firefighters and the magnitude of risk for firefighters. I put this little slide together just to show you that cardiac arrest is still one of our highest things that we deal with, and also that extreme cardiovascular strain due to work demands. Think of the day of the average worker working 8, 10, 12 hours a day, and a firefighter working 24 hours a day. And at the same time, the next day he goes to another job or just doesn't get any rest. So you're dealing with a lot of different things. This is a little funny slide I put up there about how much gear a firefighter carries. It's just something to think about, because this is exactly where we're at today. Various types of components we want them to carry, and you're looking at an overweight situation here. One of the things we did to help understand where we're at with the heat stress was the core body temperature. We did an adjustable radio pill for monitoring the core body temperature. When we did that, we found out that we had a collection of different things. We did the pre-scenario before they took it with the pill. The second one was second scenario was basically a hose line advancement. The third one was a search and rescue component. This is all exercises firefighters went through. And then we did a post-incident measurement regarding how the radio pill captured data. This gives you a little bit of a snippet of what we found. These are heartbeats going on at the same time. And you see at one time we were almost up at 180. Here you see the core body temperature on scenario 1 is like this. It goes up to about 101, a little under 101. Number 2, the core body temperature increases, and then it flattens out a little bit, and then in the last evolution, it went up to 102.5. The goal right now in the research that we're doing on the smart garment with cooling is to reduce the core body temperature and keep it at a normal rate, instead of 1 or 2 degrees can really affect someone's ability. This was a firefighter slide for a firefighter going to a building. They were approximately 4 minutes in the building and succumbed to the injuries that were there too. So these things are happening on a daily basis. We forgot, this isn't all about firefighters, but in a steel plant, look at the heat generated from operating the pouring operation of molten steel. So once again, we have all these things that in the industry that are generate heat that affects the worker. We did a lot of studies. We did an immune study on firefighters too, and it, basically the study included health effects, including cancer, diabetes, cardiovascular disease, and others. One of the reasons why this study was done, we wanted to see how many firefighters were smoking at the same time vaping, and what was going on with that. Very few did it because of they didn't want to be exposed to the fact that they smoked. But what we did find out, the chronic heat exposures modulated and initiated and adapted to the environment of the people and their health conditions. So work-related heat stress, 51% at an incident is for firefighters. Traveling to the incident is 5%. Other is 24%. Training and traveling back and forth from the incident. We're finding out once they get past this incident, over 75% of the deaths in firefighters are occurred traveling to and from an incident and at an incident during a training activity. Training is also a big activity which we have to watch closely. One of the big things that we took away was carbon monoxide and hydrogen cyanide. These two are culprits in causing cardiovascular events. Carbon monoxide, if you all know what that does, it attacks itself to the bloodstream, and it also pushes oxygen away. We're finding that the hydrogen cyanide, we have an intracellular use of oxygen resulting in hypoxia and cardiac impairment. One of the things about carbon monoxide, if it doesn't leave the body right away, which it doesn't. It takes a slow time to do that. We start seeing the effects of what happens at the myelin sheath in the nervous system. And by doing that, it deadens the senses of the firefighter or the industrial worker or whatever. So we have got to watch their CO monitoring and also hydrogen cyanide monitoring. A little thing there. Firefighter work patterns are important. We did a study on the first one we did was on 2448. We did 2472, and we watched the reduction of injuries during that period, and also how these patterns all come together. So we worked at 24-hour shifts. Police officers work 8, 10, and 12-hour shifts. Environmental impact factors that we looked at, personal risk factors, overtime, fast pace, management factors, administrative work stresses. All these are all part of the component of the public worker. Okay. One of the things I brought it into this equation with you all is NIOSH recommends 35 pounds lifting as a standard. Okay. But the firefighters today go to your home for EMS services, and also we go to where 911 is a big thing for everybody. The big problem is police officers are involved in this as well. So when we look at that, this is a typical situation responding to a home. You have a gentleman slightly obese here, and you gotta lift him up and move him. And look at the energy and the strength, and also the heat stress that even though they're in short sleeves, that could be generated from all this. This little slide on obesity, we're running a little short on time here, but you're looking at the BMI comparison, and in our area of the country right now, you're looking at a lot of people that are obese. So there again, firefighters, maintenance workers, public workers, all have suffered through this obesity issue, and how we got to get it down so they can work safely. Stress factors overall: stress level of force, repetition, posture, duration of static posture, dynamic truck movements. All these things come into play for risk factors. The international and national components of this thing. I put down the International Fire Code, which got some things in there about work, but the International Building Code has got some things also. The National Fire Protection Association has plenty, but one of the things that has a lot is this International Standard Classification of Occupations, which is a good one to look at. World Health is another one. At this time, we're kind of closing this thing up. I want to see if there's any questions. I hope you understand where I was coming with this presentation, and go from there. Thank you.
Thank you, Dr. Jetter, for such an interesting presentation. And with this emphasis on heat stress, it feels especially relevant also for our California viewers, where it's a big topic of conversation. There are a couple questions from the audience, and I encourage anybody to enter more questions in that Q&A box. The first question that I wanted to address, somebody asked about the use of breathable PPEs, personal protective equipment, if they've helped firefighters with respect to heat management. And if you could speak just a little bit more about PPE in general, I think that'd be great too.
The problem we have with PPE, it's got to meet some standards, okay? The biggest thing is I look at how this works. We're looking at the breathing. We've been through a full cycle of stuff in the fire service, and it bled over to police too. The police now are wearing a breathable T-shirt with their uniform. Actually, they use a lightweight uniform. The same thing's occurring in the fire service. We all wear T-shirts with our company logo on it and that. But we're finding out if we can lighten the garment that is more breathable, it helps sustain the temperature and keep things in perspective. And we're working on that right now on this smart garment, but the materials are interesting.
Thank you for that answer. And yeah, the smart garment seems promising, and would be interested to hear more about the development of that. There was somebody asking, I think, just a clarifying question about when you were addressing water evaporation, you had a measurement of 40 ounces of sweat, and they were just wondering per hour, or is that per body, or how are you measuring
I
that?
think that's, when we looked at data, I took it as per hour, okay? And now
Okay.
it's probably different, but it's probably per hour.
Got it. Got another question come in. What kind of standardized protections can we offer to environmental health personnel, cleanup and recovery crews, and other types of non-fire /law/EMS personnel?
I think the biggest thing is that we wear, there's a lot of garments being manufactured today. And I think the biggest thing is to buy a garment that's not so close fitting to the skin. You know, I hate to say it, but to use the analogy of like a jumpsuit type material. I know when I went through my back surgery this past year, I had a lightweight pair of pants that were pretty much, they provided insulation, but at the same time, by doing that, you can reduce the stress on the body and the mechanics of how you're doing your job. And I think that's what we got to focus on for the future. The fabric people at DAP and the University of Cincinnati are going through that right now with us on this smart garment thing. And I think the biggest thing we got to look at is that we don't reinvent the wheel. We use the materials that are available to us and incorporate that into our daily lives on a regular basis. I think firefighters should come to work, get into a nice uniform, along with police officers and also public work people. Our own maintenance department over here, we got to wear the vest and all that stuff. That weights down. I think if we can incorporate some of that in a wearable garment that works well.
Great. In that vein of the smart garment and the uniforms that personnel are wearing, I'm curious about if money was no object at all, what do you think every single fire unit in the country should be using? What kind of equipment, and also like other innovations that you wish to see in that profession?
I think in the fire service side of things, we got to figure out a way to lighten the load for these guys. And that's one of the reasons for the smart cooling garment. I think sometimes we have a tendency to think they're, pardon the expression, folks, sons of Hercules. They're carrying everything under the sun. I just think the lighter the load, the better off we're going to be.
For sure. And in terms of these fabrics, are there ways that these companies are helping to develop the fabrics to protect against chemical and other environmental exposures? So not just heat and not just like regulating core body temperature?
I think the development, all that's, it's going to go across all the industries. The Air Force and all those guys are going to be telling us, you know, we need to lighten our load with, you know, flight plans and all that good stuff. So.
I have a question specifically. Somebody was asking about respiratory protection as well in terms of garments, masks, etc.
Well, we've been through a real trying time with COVID, and masks are great. My feeling is if we're using any type of thing in an industrial setting, if there's any chemicals of any area, they should use a respirator that's basically geared for that environment. If it's the fire service, we naturally wear an SCBA. Police officers now with the CBRN and other type of things are wearing a cartridge type mask that'll help too. The problem is people got to understand when you put a respirator on, you're putting yourself in a situation for a deeper call for inhalation and things like that. As far as it's a little harder to breathe through a mask. That's what it boils down to. And I think the biggest thing is that they got to look at that and say, hey, you know, this is what I got to do to protect my respiratory tract, and that's important. Now they make all types of paper masks. Now they make all types of cloth masks, and that since COVID came around. I'm a strong believer that you got to protect your respiratory tract.
Certainly. I had a question myself. You mentioned two chemicals that firefighters are often encountering, and that's carbon monoxide and hydrogen cyanide.
Right.
Carbon monoxide, I think about a gas stove leaks in that case, but where are they encountering hydrogen cyanide? Where does that come from?
That's a product of combustion. So if we get a fire in a house and you got household materials burning, furniture, those type of things, you're seeing the hydrogen cyanide being produced. And that is becoming more and more prevalent because we're dealing with a lot of synthetic materials, and we're looking at furniture that has a lot of glue in it. And we're also looking at just regular general building materials that are now in that fashion. So it's all around us. And when you have a car fire, it's the same thing. You get, the upholstery in the car and all that is loaded with carbon products, and hydrogen cyanide is a byproduct of that.
Thank you for that explanation. We probably have room for one or two more questions if anybody wanted to enter a question into the Q&A. I have a question for us in California. We hear so much about wildland firefighters and fighting these huge fires in our state. And I'm curious if there are specific types of equipment that you've encountered or specific issues around industrial hygiene when it comes to these big wildfires.
Well, wildland fires is its own unique animal. I don't mind telling anybody. Firefighters wear a lighter weight gear, and they do wear. I had at one time I did carry a mask that you could put on. It wasn't real bulky. It was just to help filter the smoke out. And those guys go through a tremendous amount of heat along with anything else. And I think the biggest problem with wildland firefighting is the fact that it's a moving, changing animal at a moment's notice. And that's one of the biggest problems with wildland firefighting. Containment can be a real difficult charge for firefighters to go in and try and do that. I just really agree with all that. So.
I hear you. There's one more question about are firefighters given physical stress tests after a certain age or physical ailment to prevent cardiac events? So if somebody's a firefighter for a while, are they continually getting these tests, or is it
Yes.
a kind of just in training? It's
In
so it
in
happens
Ohio,
over
because of
time.
workers' comp, they have to go through it, whether they like it or not. And I was the full-time fire chief at Sycamore Township. That was one of the things in our annual physical. They had to go through a stress test.
Got it. Somebody is wondering if you're willing to give out an email address
Yes,
if
I'll give
they're
it to you
trying to
right now.
contact you.
I'll give it
Yeah,
to you right now.
if you are willing to just put that in the chat, that would be great.
I'll do it right now for you. Okay.
Somebody in the chat also mentioned the Bureau of Workers' Compensation. They're a research librarian for the Ohio BWC library. They also dropped a link for anything related to safety research, resources, materials. I'll just copy that link so that everybody has it.
Okay.
It looks like here, I'll make sure that it's in the chat. There we go. All right, we're just about at the end. Dr. Jetta, I just wanted to thank you so much for this presentation. If you have any last words that you'd like to share.
Well, I hope I didn't bore anybody. I was just trying to give you a little insight of where we got research has got to go. And I appreciate your kindness and everyone's patience with me. I took this program just to make you laugh a little bit from 200 slides down to where we're at today. So I had a lot of data in there, and I thought, my God, those people will kill me if they get something like this. So to make a long story short, thank you for your patience. I enjoyed it, and I hope I help you all out. Okay.
Thank you so much. And I can say for my part, it was a very engaging presentation, and we appreciate you sharing your research.
Thank you.
All right, everybody. Enjoy the rest of your day, and we'll see you at our next webinar. Thank you.
You all have a great holiday weekend too. Okay.
Thank you.
Bye. Thank you.